Hello, good evening everyone. Welcome to BYJU'S Exam Prep, most comprehensive competition platform. So yes, the voice is clear, voice is absolutely fine. So I hope, yes, good evening Karthik. So please share the session everyone so that the maximum students can join quickly and we will start our session. Okay, so let's share the session with your friends. So I am also sharing, you can also share with your all of your friends. So then we will discuss our Super 11 questions of EMFT. I hope that all the topics of EMFT you have prepared because we are going to cover a broad range of the questions. Yes. Good evening, Rupesh. Good evening, TK. Yes. So let's start the session. And before starting the session, wait a second. Yeah. So that's okay. That is okay. That is also okay. So all of you, please tell how is your preparation going on? Means are you comfortable now in all the subjects, or are you still facing some doubt? Are you still facing some problem, or you have cleared with all the topics and now you are comfortable in all the subjects and now you are ready to you are ready for the GATE examination. I hope. Just wait a second because I'm setting up the chat box. Yeah, so before starting the session, let me introduce myself. So this is Saket Verma and I have done MTech from IT Guwahati and I have more than 12 year experience. So here you can see what are the different sessions we plan for you. Okay, here is the chat section. Okay, so let me see the chat section over here. Yes. So Tanveer, Surya Prakash, Nikhil, yes. So everybody has joined now. So let's start the session and sorry for the delay because the chat section I was not able to connect. So there is a session for your juniors. You can share the particular session for to your juniors. That is Sanjay Latis that is going to take this session today 7:30 p.m. And there is a GATE exam analysis that we are going live and we are coming live for all of you on the 5th of February. So you can come up with your queries, the GATE examination if you have any doubt and if you want to check your answer then you can come and join live and for that you have to subscribe this channel. Okay, so this is the first question for you. This is the first question for you. Yes, solve this question. A 500-meter long transmission line has a phase angle 150 degree of reflection coefficient, okay, of reflection coefficient at the load, and if the operating wavelength is 150 meter, then the total number of voltage maxima we want to get. Okay, the total number of voltage maxima we want to get. Come on. So solve this question. So I'm giving you the timer also. So I think yes. So Dreamer has answered this particular question. So the correct answer is 7. The correct answer is 7. Good evening. So here you can see that the length of the transmission line is given, which is 500 meter, and the phase is also given 150, and the wavelength is also given as 150. So we want to calculate the total number of maxima. Then we know that this, how do we calculate the distance of maxima? So this is pi minus 2 beta Lx, 2 beta L max should be equal to integer multiple of, even multiple of pi, you can say. So this is 150 degree. So 150 into pi upon 180 degree. So we are converting into a radian. So this is 2 into 2 pi upon lambda. Okay. And the maximum length you have to write 500. We want to calculate. And because this is minus 2n into pi. So when you will solve it, you will get n is equal to how much? 7.08. Okay, 7.08 or 7.06 approximately you will get. And so the number of voltage maxima would be 7. Okay. So from here you can calculate. This is the formula that you have to use. L is there, na? L is 500. L is the 500. We are keeping the length as 500. So this is 2 into 2 pi by lambda, that is beta, and L is 500 and minus 2 and pi. So here you will get result is pi, and then we will solve it for n. And lambda is also given 150. So you can substitute the value of lambda. Yes. Okay, very simple. And there is one way to solve, another way to solve this question is by the Smith chart. By the Smith chart also you can calculate. Okay, by the Smith chart also we can calculate. So do you know the procedure to calculate the using Smith chart? So this is the method number 1, and this method number 2 can be with the help of Smith chart. Okay, so there is a second method by which you can solve, that is the Smith chart. That is because the phase is positive, so the load will be inductive. And if the load is inductive, then you will be in the upper half of the Smith chart. Then you will calculate by complete rotation, that is 3 wavelength. 3 wavelength means you will travel approximately 450 meter. So that 450 meter you will cut the voltage maxima 6 times, and now for the remaining 50 meter you have to calculate the distance in terms of wavelength, and at that angle you have to rotate from the given point, that is 150 degree, and then you have to check whether you are crossing the voltage maxima or not. Okay, so first of all 3 lambda, that is equal to 1 lambda is equal to how much? 720 degree we say. Okay, so that is your 6 rotation, because lambda by 2 distance means 360-degree rotation. So that means this time you will cross the voltage maximum one time, and you are using 3 lambda. So that means you will be going to multiply it with the 6. So that is equal to 3 lambda. So 6 times you will cross the voltage maxima, and for the remaining 50 meter also you can calculate, and you will get the voltage maxima crossing the on the Smith chart. You know that in the Smith chart, okay, in the Smith chart, this is suppose Smith chart unit circle. So this is the point of voltage maxima, and this is the point of voltage minima. So this particular point you are crossing 6 times when you are traveling 450 meter. So 450 meter is equal to 450 meter traveling means you are crossing 6 times. Okay, 450-meter traveling means 6 times you are crossing, 6 times crossing the voltage maxima. For the remaining 50-meter, for remaining 50-meter also you can calculate. For remaining 50-meter, you have to calculate the angle. Okay, how many degree you have to rotate, and that you can calculate. If the lambda by 2 is equal to 360 degree, then you can calculate it for 50-meter also. Like, that is, you can say 75-meter is equal to 360 degree, then 50-meter is equal to how much degree? So this is 360 divided by 75 into 50, so that is your 120 degree. So 120 degree. So for remaining 50-meter, you have to travel 120 degree, and 120 degree means that will again cross the voltage maxima, because you are already in the 150 degree. So you are already in the 150 degree, and from 150 degree, when you will rotate it by 120 degree, you will again cross the voltage maxima. So already 6 times you have traveled, and for the remaining 50-meter, you will travel one more time. So total of 6 plus 1 equal to 7. Okay, next question. Solve this question. Come on, quickly solve this question. A wet marshy soil is characterized by sigma equal to 10 to the power minus 2 Siemens per meter. Epsilon is equal to 15 10 to the power minus 9 upon 36 pi farad per meter. Mu equal to 4 pi into 10 to the power minus 7. This distance traveled by a 60 hertz wave for its amplitude to get reduced by 20 dB. Yes. So, TK, in the last question, we have already in the 150 degree, right? We have already in the 150 degree. So, if you calculate the angle from here, where will be the 150 degree? Okay, 150 degree will be 90 plus 60 right here. This will be your 150 degree, right? So, from 150 degree, if you will rotate it by again 120 degree. So, is it 120 degree or something else? Mm, I think this particular angle is 240. It should come as a 240. So if it is, check this angle particularly, 50 meter we should get. Yeah, it is 240 now, because I have forgot to multiply with this 2. So you have to travel another to 240 degrees. So when you will measure the 240 degree again. Yes. Okay, so then 240, then it will again cross. It will be 240, not 120. This 2 we have forgot to write. Okay, this 2 is there now. So this is 75 and this is 3. So 3 and 120, this is 120. 120 into 2 is 240. So 240 actually. Now solve this question. So because sigma is given, it may be the conductor or it may be the lossy dielectric. So first of all, we have to calculate the sigma upon omega epsilon. So this is sigma upon omega epsilon. If you will substitute, then what is this? 10 to the power minus 2. Omega is your 2 pi into f, that is 60, and epsilon is 15 into 10 to the power minus 9 by calculating the loss tangent. I don't think so. You need only alpha. You need only alpha. So when you will calculate it, you will get 2 into 10 to the power 5, which is very, very greater than 1. Hence, this medium will be said to be as good conductor. Okay, so if it is good conductor, then alpha is given by root over pi f mu sigma. And when we substitute the all the values, pi into f is 60, mu is 4 pi into 10 to the power minus 7, and sigma is 10 to the power minus 2. Then if I substitute the value of alpha, I am getting as 0.00153. Okay, so now we want to calculate the reduction in the amplitude while traveling the 20 dB. So when we say the 20 dB, what does it mean? 20 dB means it is nothing but a by factor 10. Okay, it will reduce by factor 10. So electric field which has the maximum value E naught, it should reduce by factor 10 to have the reduction in amplitude by 20 dB. So this is E naught e to the power minus alpha into z. So this E naught and E naught will get cancelled and we will get 0.1 and e to the power minus alpha z. Alpha we have calculated. So we will take the natural log both the side. So natural log of 0.1 is equal to minus alpha into z, and hence we get the value of z is equal to how much? Anyone? So we got 1496. So the answer is 1496. 1496 meter. Okay. So 1496 meter we will get. 1496 meter we will get. Next. The question is the expression of an EM wave in the lossy medium is given as E equal to 0.4 e to the power minus z by 3 sine times power 8t minus beta z ax cap if for the given medium mu r is 1, if for the given medium mu r is 1 and epsilon is 8, the loss tangent and the phase velocity is given by. Yes. So the answer is option B. Correct. Answer is option B. That's correct. Okay, because first of all, in the given expression, we will come to know about alpha, which is 1 by 3. And the formula for alpha is for the lossy medium because it is already mentioned. So mu r upon epsilon r. And here we will get a root over 1 plus sigma upon omega epsilon whole square minus 1. That is bracket closed. So from here, when you will calculate, you have to substitute all the values. Here, all the values are given. Omega is 10 to the power 8. C is the velocity of light. Okay, so let me write one more line here. So this is 1 upon 3. Omega is 10 to the power 8. And velocity of light is 3 into 10 to the power 8. And root over mu r is 1. Epsilon r is 8 divided by 2 root over 1 plus this sigma upon omega epsilon whole square minus 1, and this sigma upon omega epsilon is nothing but a loss tangent. So from here, when you calculate the sigma upon omega epsilon, you will get 3 by 4. Okay, you will get 3 by 4. It is very easy. This 10 to the power 8 will get cancelled, 3 and 3 will get cancelled, and when we square it, we can easily calculate. Okay, so this is the first thing that we have got. And because it is the lossy medium, we have to calculate the phase velocity, and to calculate the phase velocity, we need a beta because we know that the formula is omega by beta. And what is the formula for beta? There is only one difference in the calculation, that is instead of minus 1 we have plus sign. So 1 plus sigma upon omega epsilon whole square plus 1. That is the formula of beta, right? So omega epsilon we know, and when we calculate the beta, the value of beta we will get as 1. The value of beta we will get as 1. So this is 2 pi into, sorry, uh, omega is directly given, na? So 10 to the power 8 divided by 1. So we get 10 to the power 8 meter per second. That is option B. Yes, Ashok, this is not for double E. This is not for double E. Okay. So read this question and now solve it. Yes, TK, you can also calculate. No, by that all phase velocity you cannot calculate by that because it is not a lossless medium. This is not a lossless medium, Janvi. So आप calculate नहीं कर सकते हो इसको. Beta we have to use this formula only because this is a lossy medium. Okay, so this is a lossy medium, so you cannot calculate the beta by any other method. Okay, that will give you the approximate result, but that will not be a good practice because for the lossy medium, we have the formula of alpha and beta like this. Okay, that is just the approximated value. You may get some close answer, but it is not always true. Now answer this question again. We have to put the timer because that timer has gone. This is bit lengthy question, so that is why I gave you again another 2 minutes for this. So down by 10 dB, down by 10 dB, down by 10 dB means yes, the power will be a factor of 10, correct. इलेक्ट्रिक फील्ड रिड्यूस बाय 10 dB दिया रहेगा तो आप उसको 20 dB से कन्वर्ट करोगे, है ना। जैसे कि अगर आपको मान लो इलेक्ट्रिक फील्ड रिड्यूस बाय 10 dB दिया है ना, तो ये 10 dB दिया हुआ है आपको। अगर तो आप इसको ऐसा लोगे 20 log ऑफ सपोज द फैक्टर x, तो यहाँ से हम लोग निकालेंगे 1/2 वैल्यू आ जाएगी, x की वैल्यू नहीं आएगी, सॉरी कहाँ चला गया, यस। तो ये आ जाएगा 1/2, ठीक है, और log x होगा ये। फिर आप ये 10 टू दी पावर 0.5 कर लोगे तो x आ जाएगा। और जितना भी आपका इलेक्ट्रिक फील्ड होगा पीक वैल्यू ई नॉट, वो 10 टू दी पावर 0.5 फैक्टर से रिड्यूस हो जाएगा। ठीक है, अभी ये प्रीवियस क्वेश्चन में किए भी थे। ठीक, anyways, now in this question we have to solve, and first of all we will calculate the tan theta, which is sigma upon omega epsilon, and this is sigma upon omega epsilon. यहाँ पे आपको permittivity is given epsilon 2 divided by epsilon 2 dash double dash and single dash, that is nothing but a ratio of the complex part of the complex permittivity, sorry, imaginary part of the complex permittivity and the real part, which gives the ratio equal to loss tangent. So this is 0.05. So it is less than equal to 1. So we will call it as a lossy dielectric. So in case of lossy, we have the general formula. So we will calculate the magnitude of eta 2, which is root over mu by epsilon. Yes, मैं एक बार आता हूँ आपके क्वेश्चन पे, जानवी, जस्ट वेट। सो रूट ओवर 1/4, ओके। सो यहाँ पे आप इसमें सारी वैल्यूज कैलकुलेट करो, यहाँ पे सब्स्टिट्यूट करोगे तो 120 पाई डिवाइडेड बाय √5, क्योंकि एप्सिलॉन आर की वैल्यू √5 दी हुई है ना, तो ये √5 हो गया। और 1 प्लस 0.01 होल स्क्वायर होल टू द पावर 1/4। हाँ, लो लॉस ले सकते हो, यस, ठीक है, यू कैन टेक लो लॉस ऑल्सो। Okay, low loss also you can take, no problem at all. Okay, low loss also can be taken, but I am taking this one. So you can calculate it by low loss. Obviously, the simplification will be there, because it will give you approximately 875 divided by root. Calculation will be simpler, है ना। ठीक है, तो यहाँ पे अब आप थीटा निकालोगे तो थीटा आ जाएगा आपका 1/2 tan इनवर्स ऑफ सिग्मा अपॉन ओमेगा एप्सिलॉन, जो इसको कैलकुलेट करने पे ये आ रहा है 1.43। तो अगर आप इसको अप्रोक्सीमेट करते हो तो ये थीटा ईटा की वैल्यू अप्रोक्सीमेटली 0 हो जाएगी। फिर यहाँ से हम लोग रिफ्लेक्शन कोफिशिएंट निकालेंगे, क्योंकि हमको निकालना है कि कितना पावर ट्रांसमिट हुआ था। तो यहाँ से आपका ईटा 2 माइनस ईटा 1 डिवाइडेड बाय ईटा 2 प्लस ईटा 1 करके कैलकुलेट करो। सो यहाँ से कितना आ रहा है ये वैल्यू बता सकते हो क्या रिफ्लेक्शन कोफिशिएंट का, इफ यू आर अप्रोक्सीमेटिंग इट टू द लो लॉस, देन लो लॉस के केस में थीटा ईटा 0 हो जाएगा, मैग्नीट्यूड तो यही आएगा, लगभग लगभग 120 पाई डिवाइडेड बाय √5 आ जाएगा, है ना। 120 पाई मतलब 377, इस केस में 877 आ रहा है। एक सेकेंड ना, इसमें कुछ कैलकुलेशन आई थिंक मैं 377 ही होगा ना वो, 377 ही है क्या? एक सेकंड रुको मैं चेक कर लेता हूँ। 877 डिवाइडेड बाय रूट फाइव, तो डिवाइडेड बाय रूट फाइव 392, 392, तो यहाँ पे ये गलत है, ये 377 होना चाहिए। 377, यस, दिस इज 377 नॉट 870, ऑब्वियसली दिख ही जाता है ये, क्योंकि 877 कैसे हो जाएगा, है ना? तो ये 377 बाय रूट फाइव है। ठीक है, तो ये 377 बाय रूट फाइव है, तो यहाँ पे आप इसको ऐसा कर लो कि 377 डिवाइडेड बाय रूट फाइव ले लो, और माइनस, बिकॉज वी आर यू कैन अप्रोक्सीमेट इट टू लो लॉस, so for low loss this theta eta will be zero, तो आप इसको ऐसा कर सकते हो। अगर लो लॉस लोगे तो अल्फा को छोड़ नहीं सकते ना, अल्फा तो आपका मेन पार्ट है। ठीक है, तो अगर मान लो मैं इसको लो लॉस लेता हूं, इफ आई टेक लो लॉस, ओके, देन व्हाट विल बी द फॉर्मूला, उसके अकॉर्डिंग मैं इसको कैलकुलेट कर देता हूँ। सिंपली कैलकुलेशन सिंपल हो जाएगा, इसलिए अपन ऐसा कर रहे हैं कि लो लॉस ही ले ले रहे हैं, है ना? तो यहाँ से आ जाएगा 120 पाई डिवाइडेड बाय रूट फाइव, जो कि 377 डिवाइडेड बाय रूट फाइव है, और पहला तो आपका फ्री स्पेस है 377, सो 377 डिवाइडेड बाय रूट फाइव प्लस 377, तो रिफ्लेक्शन कोफिशिएंट कितना आ रहा है? रिफ्लेक्शन कोफिशिएंट कितना आ रहा है? -0.38, ओके, तो -0.38 आ रहा है। ओके, सो दिस इज -0.38, बट कितना पावर ट्रांसमिट होगा अगर मुझे ये निकालना है, तो पावर ट्रांसमिटेड कितना होता है, जितना पावर आपने इनपुट में दे रहे हो, 1 माइनस मॉड गामा स्क्वायर इतना होता है। ये लॉसलेस के लिए, अब लॉसी है तो e⁻²ℎ जेड का भी मल्टीप्लीकेशन करना पड़ेगा। ठीक है, तो यहाँ पे वही डिस्टेंस तो निकालना है, तो ये जो टोटल पावर जो ट्रांसमिट हो रहा है वो कितना है? एक्चुअल पावर जो 5 वॉट पर मीटर है उसका 10 डीबी डाउन, तो 10 डीबी डाउन पावर है, तो यहाँ पे आपका जो भी इनपुट पावर होगा उसका कितना हो जाएगा, ये डिवाइडेड बाय 10 हो जाएगा, और इनपुट पावर कितना था, 5 था। 1 माइनस मॉड गामा स्क्वायर, तो इसको आप 0.38 का स्क्वायर कर दो। ठीक है, और e⁻²⁻² अल्फा, और ये z आपको निकालना है। अब अल्फा कहां से निकालोगे, तो अल्फा का वैल्यू कितना होता है, सिग्मा बाय 2 रूट ओवर म्यू बाय एप्सिलॉन फॉर लो लॉस। ठीक है, अब दिक्कत यहाँ पे आपको यही आएगी कि सिग्मा की वैल्यू तो नहीं पता है, तो इसलिए हम यहाँ पे क्या कर लेंगे, हम यहाँ पे जनरल जनरल फॉर्मूला यूज कर लेंगे, तो जनरल फॉर्मूला के अकॉर्डिंग हमारा ओमेगा बाय सी रूट ओवर म्यू एंड एप्सिलॉन बाय 2, सिग्मा की वैल्यू नहीं पता थी ना, तो हाँ ठीक है, और रूट ओवर 1 प्लस सिग्मा अपॉन ओमेगा एप्सिलॉन का होल स्क्वायर -1। ठीक है, तो ये फॉर्मूला यूज कर लेंगे, तो यहाँ पे हमारे पास सिग्मा बाय ओमेगा एप्सिलॉन तो ये 0.05 है, म्यू और आर यहाँ से हमको मिल जाएगा, ये म्यू और आर सेकंड मीडियम के लिए दिया जिसमें ट्रेवल कर रहा है, तो अल्फा मुझे कौन से मीडियम में निकालना है, जिसमें वो ट्रेवल कर रहा है, मतलब फ्री स्पेस के बाद जिस मीडियम में गया, तो ये पहले आपका फ्री स्पेस में था, फ्री स्पेस से ये लॉसी में गया, तो लॉसी मीडियम का अल्फा निकाल रहे हैं हम लोग, फ्री स्पेस का तो अल्फा नहीं निकालेंगे, जीरो होगा, तो अल्फा की वैल्यू कितनी आ रही है यहाँ से, ये आएगा मेरा 1.17 इंटू 10⁻²। ठीक है, मैं कैलकुलेशन कर रखा हूँ ताकि आपका काम इजी हो जाए, यहाँ पे ज्यादा टाइम अपन वेस्ट नहीं करेंगे, है ना? तो ये अपना 0.1 आ गया, और 1 माइनस 0.38 का स्क्वायर आ जाएगा, और e टू दावर -2 इंटू अल्फा, अल्फा की वैल्यू 1.17 इंटू 10⁻², और यहाँ से सिर्फ z आपका अननोन है। ठीक है, यहाँ से सिर्फ और सिर्फ आपका z अननोन है, और जब z का आप कैलकुलेशन करोगे तो वो आएगा 91.6। ओके, तो मैं आपका काम थोड़ा सा आसान कर रहा हूँ, यहाँ पे मैं z का वैल्यू डायरेक्टली आपको निकाल के बता रहा हूँ कि ये 91.6 है, अप्रोक्सीमेटली, है ना? अप्रोक्सीमेटली आएगा, क्योंकि हम लोगों ने यहाँ पे ये गामा को अप्रोक्सीमेट किया हुआ है, ये ईटा को अप्रोक्सीमेट करके। ठीक है, थोड़ा बहुत आगे पीछे हो सकता है, बट वो आपका जो गिवन रेंज रहेगा उसका आ जाएगा। ठीक है, ठीक है, तो ये आया कि नहीं आया सभी का? इसमें कोई डाउट हो तो बताओ, इसमें कोई डाउट हो तो जल्दी से बताओ। यस, 91.66 आ गया है करेक्ट, अप टू डेसिमल नंबर 1 तक हम उनको देना है आंसर, तो हम आंसर जो एग्जाम में डालेंगे वो होगा 91.6, या अगर 66 आ रहा है तो आप 91.7 भी पुट कर सकते हैं। चलो नेक्स्ट ये वाला क्वेश्चन सॉल्व करो। जानवी उसको लेता हूँ मैं, आपको डाउट है ना। जानवी उसको लेते हैं अपन, आप वेट करो थोड़ा सा, अपन थोड़ा सा क्वेश्चन सॉल्व कर लेते हैं, फिर लास्ट में मैं आपके इस डाउट को लेता हूँ, ठीक है। आप याद रखना रिड्यूस्ड बाय और रिड्यूस्ड टू में क्या डिफरेंस है, तो एकदम माइनर डिफरेंस है, आपको मैं लास्ट में बता दूंगा, ठीक है। तब तक आप ये क्वेश्चन सॉल्व करो। एक आंसर मेरे पास आ चुका है एंड इट लुक्स करेक्ट। या सो द करेक्ट आंसर इज बी ओनली, द करेक्ट आंसर इज बी ओनली। Okay, so first of all, cutoff frequency, yes, cutoff frequency for TE10 है ना। यहाँ पे TE10 कोई एयर फील्ड तो दिया नहीं हुआ है, तो हम लोग लेंगे VP अपॉन 2 इंटू M बाई ए, राइट, M बाई ए ये हमारा प्लस N बाई बी होल स्क्वायर। चलो मैं एक बार लिख ही देता हूँ, ये होता है हमारे कट ऑफ फ्रीक्वेंसी का फॉर्मूला। अब TE10 के लिए लिखना है तो VP अपॉन 2A होगा, ठीक है, VP अपॉन 2A हो जाएगा, ठीक। और यहाँ पे a इज इक्वल टू 2b है, याद रखना a इज इक्वल टू 2b है, ठीक है। और एफ सी इक्वल टू यहाँ पे क्या आ जाएगा, TE20 मोड के लिए अगर निकालना है, TE10 TE20 के लिए हो जाएगा VP अपॉन a, ठीक है, VP अपॉन a हो गया। अब आ जाओ आप एफ सी टी एम वन वन के लिए, तो वन वन के लिए निकालेंगे तो VP अपॉन 2 यहाँ से आ गया 1 बाई ए का होल स्क्वायर प्लस 1 अपॉन बी का होल स्क्वायर, कट ऑफ फ्रीक्वेंसी का फॉर्मूला। अब यहाँ पे अगर मैं ए के टर्म्स में लिखना चाहता हूँ तो B इज इक्वल टू ए बाई टू होगा, ठीक है, B इज इक्वल टू ए बाई टू होगा, मतलब यहाँ पे आ गया 4 अपॉन ए स्क्वायर। सो कितना हो गया, VP अपॉन 2A मल्टीप्लाइड विथ √5, ठीक है। और कट ऑफ फ्रीक्वेंसी फॉर TM क्या बच गया, 1 2 के लिए कितना हो जाएगा, VP अपॉन 2 रूट ओवर 1 अपॉन ए स्क्वायर एंड 2 अपॉन बी, बी इज इक्वल टू कितना, a by 2, so this is a by 2। now this is the VP upon 2a root 17, okay, so this will be root 17। now you can tell which one will be giving you the lowest cutoff frequency. So this is lowest cutoff frequency because we know that if A is greater than equal to 2B, then it is a dominant mode and dominant mode gives the lowest cutoff frequency. So this will be giving you the lowest one. Then this is VP upon A, this is VP upon 2A multiplied with √5. So obviously it is greater than TE 20. Wait. Here you have said a TE20. Okay, yeah. So the answer is this one, na? Option D. Answer is option D, not B. All of you are telling answer B, but the answer is option D. Now tell me, do you have any doubt in this? Because this is VP upon 2 into A and √5. And what is the value of √5? It is 2 point greater than 2, na? It is 2.236. So it is 2.236. So obviously it is greater than VP upon A. So VP upon A, it is greater than VP upon A. So the answer is option D. Answer is option D because TE11 is not even given in the question. How this will be happening? Root 17. What is the value of root 17? The root 17 is 4.23, and when we divide it by 2, wait a second, let me divide it by 2, we are getting 2.06. So this is TM में problem D में. Uh, this is maximum, right? GE10. Yeah, yeah, yeah. Correct, correct, correct. It is option A. It is option A, right? It is option A. This is 2.06. It is 2.06 multiplied with VP upon A. It is 2.06 times, and it is something 1.0 something. Okay. So this is 1.1 something. आएगा. ठीक है? Yes. Option A. Option A will be the right answer. Not B, not D. Neither B nor D. Correct. Option A. Okay, so just don't directly give the answer. Just first of all, you have to write because it is TM na. So that is why it is important, because it is TM. So that is why it is important that how we are calculating. Okay. Now next one. Solve this question. Solve this question, guys. My laptop is running out of battery, so let me correct it. Solve this question till then. So what is the answer? What is the answer for this question? So here what is given? Okay, so D is equal to lambda, alpha is 0. Okay, so what is the normalized array factor? So the normalized array factor is cos of xi by 2 mod, and we want, because we want null, then the normalized array factor has to be 0. Okay, so for that this xi by 2 has to be plus minus pi by 2, and the xi is alpha plus beta d cos theta divided by 2 is equal to plus minus pi by 2. Alpha is 0, and this is 2 pi, this 2 and 2 also get cancelled, so this is 2 pi by lambda, d is lambda, and cos of theta is equal to plus minus pi. So again this pi and pi will get cancelled, and lambda and lambda also get cancelled. We will get cos of theta is equal to plus minus 1 by 2. Okay, so what are the different values where we can get this 120-degree and 60-degree? So that is option C. Okay, for theta is equal to pi by 3 and 2 pi by 3, we get plus minus 1 by 2. Okay, now solve this question. Yes. So the answer has come, that is 9. 9 is the right answer. 9 is the right answer because in this question it is given that if the amplitude of the reflected wave, that is E1 minus, okay, here you can see that this is the E1 minus, okay, which will be reflected. This is E1 plus, so E1 minus will be the reflected wave this side. So this is E1 minus, okay, and the amplitude of the reflected wave E1 is one half of the E1 plus. So from here you know that the reflection coefficient is E1 minus divided by E1 plus, which is 1 by 2. Okay, both the medium are lossless. Then we can say that this is eta z less than 0 is unknown and this is free space. Okay, this is free space, right? Yeah. So this will be eta 2 minus eta 1. So this will be epsilon r1 minus root over epsilon r2 divided by root over epsilon r1 plus root over epsilon r2. Right? And this is the free space. So for this will be 2 root over epsilon r1 minus 2 equal to root over epsilon r1 plus 1. So this is root over epsilon r1 is equal to 3 and hence you get epsilon r1 is equal to 9, which is the relative permittivity of the first medium. Epsilon r1 is equal to 9. Next question. What is the answer? Come on, last 13 seconds. Answer is C. Right? Answer is C. Sorry, D. D is the right answer. Correct. Answer is D. Because for lossless, okay, for lossless, we should check S11 mod square plus S12 mod square equal to 1. For lossless, for the two-port network to be lossless, this condition should be satisfied. So this is 0 and for the mod of the second, this is 1. So this is equal to 1, hence lossless. And for reciprocal, this S12 is equal to S21. So this is S12 in this question. S12 is not equal to S21. Hence, Non-reciprocal. Okay, so option D, lossless and non-reciprocal. Next. Okay, again, this is the question from array. So you don't know. So the directivity of a broadside, right? Directivity of the broadside is given by 2 nd upon lambda. Okay, and 2 into number of isotropers is 50. So this is 50 into d. D is the distance element space, which is lambda by 2, and this is again lambda. So the directivity is 50. Very easy question. Direct formula based question, but if you don't know the formula, then it happens. Okay, so this is D is equal to 50. Now solve this one. Again, if you have not studied, then you will not be able to solve it. A Hudson dipole of length lambda by 100 is located at origin free space and fed with a current of 0.25 sine 10 to the power 8. Okay, this is sine 10 raised to power 8t. This is sine 10 raised to power 8t. This is the power 10 to the power 8t. Okay, 10 raised to power 8t, that is the omega. Then magnetic field at point theta is equal to 30 degree, which is at lambda by 5 from the antenna. So we know that at far field only E theta H phi exists. So that is nothing but a eta we don't know, need to write because that is H. It is H, and in case of electric field we get eta. So this is I naught dl sine theta into beta, that is what I am writing as magnitude upon 4 pi r. I naught dl sine theta into beta upon 4 pi r. And e to the power minus j beta r. This is a phi. Let's write, because the phase is also given here, so we should not write in magnitude. We should not write in magnitude here. We should write in with the angle. So that is H phi s is equal to j also comes because j beta into I naught ds sin theta e to the power minus j beta. Okay, so this is j. I naught is given, which is 0.25 sine 10 to the power 8t. dl is lambda by 100. and theta is 30 degree, then e to the power minus j. And what about beta? Beta we can write it as 2 pi lambda, and distance we need to calculate at lambda upon 5, and a phi cap divided by 4 pi distance, again lambda upon 5. I not dl. Dl is okay. Yes, dl is there. So now when you calculate it, you will get, I am writing the answer, 0.1658 sine 10 to the power 8t plus 18 degree. That is now your work, how you will get this. Okay. Just you need to write all the things here, that lambda and this lambda will get cancelled, this lambda and this lambda will get cancelled, and just calculation you have to perform. This j is having the angle, so you will get the option C. Beta ka value, this is 2 pi by lambda. Yes, we have forgotten this beta. Beta is 2 pi by lambda, also you have to substitute. Beta you have to write. Yeah, 2 pi by lambda also you have to write. Okay. And yes, what is the lambda? Lambda is C upon F, the frequency, or you can directly calculate. This is omega, you have already 10 to the power 8. So you can calculate this 3 into 10 to the power 8 divided by omega, which is 10 to the power 8 divided by 2 pi. Okay. So 10 to the power 8 divided by 2 pi. So here you will get 6 pi. So the value of lambda is 6 pi. The value of lambda is 6 pi. Then you can substitute all the values. Okay. So this is the main formula and just formula based question, but you have to remember these formulas. That is, at far field you should know the equation of electric field, because in case of antenna array it is the important expression. It was direct question, not tough. Just a calculation. It was a direct question. It was not that tough. This one is not lengthy. You can see that if you calculate the power from this side and this side, that will come same, because the load is same, the characteristic impedance is same, length is same. So if I say this as a Z in 1 and this as Z in 2, then the load of this will be ZL, and which will be nothing but a Z in 1 parallel with Z in 2, okay, divided by 2. Sorry, no, yeah, Z in 1 in parallel with Z in 2 only. And what is the value of Z in 1 and Z in 2? This is nothing but a Z naught square upon ZL. So it is 50 whole square divided by ZL, which is 100 plus J 30. So when you calculate it, you will get 22.94 plus J into 6.88. Okay, so because these are in parallel and both are same, so the load impedance we will get as half of that, which is 11.47 plus J 3.44. Okay, is it clear up to this point? Now, what is the current? Now, if I want to calculate the current, that is the total applied voltage divided by ZG, that is the generator, and the load impedance. So, this is 10 at an angle 0, and ZG is 100 plus J50, and ZL is your 11.47 plus J 3.44. So if you will calculate the current, then you will get 0.073 minus J 0.035 ampere. Okay, and if you calculate the complex conjugate, then also you can calculate, because why we need complex conjugate? Because if we want to calculate the average power, it is 1 by 2 real part of voltage and the current complex conjugate. Okay, so this is 1 by 2, and what is your voltage? That is, you have to calculate the voltage again by the voltage division rule. Okay, so let me write over here, that is the voltage VAA, let us suppose that is your VA multiplied with ZL divided by ZL plus ZG. So from here, if you will calculate, how much it is VA, when you will substitute all the value. What is the value of VA? VA is this one, 10. ZL we have calculated. Where is ZL? This is ZL. And ZG, this is ZG. Okay, this is ZG, which is 100 plus J50. So when you substitute all the values, 0.96 plus 0.96 minus J 0.15 it is coming. Okay, so now we will substitute the real part of V in. V in I am writing as V in, which is now VAA. So 0.96 minus J 0.15 multiplied with the complex conjugate of I, which is 0.073 plus J 0.035, bracket closed. So then when you calculate it, you will get 0.037. 0.037 watt. So answer is option C. Tell me whether this part is clear or not. Yes, I agree on that, that it may be tough to calculate it from the virtual calculator. But yes, the procedure you should keep in mind, because sometimes they give the questions, some lengthy questions in the examination, but mostly they can avoid also in the GATE examination. ठीक है, तो चांस है कि नहीं भी आए, बट अगर आएगा तो आपको पता होना चाहिए कि हाउ टू कैलकुलेट द पावर डिलीवर्ड. ठीक है. Okay, now coming to the Janvi, is there or not? Janvi present or not? So, if suppose if electric field is reduced by factor 10, okay, reduced by factor 10, if it is given, then this is nothing but a E naught divided by 10, okay. If electric field is reduced by 10%, okay, let us say 20%, reduced by 20%, then how do you write? Reduced by 20% means you have to write 1 minus 0.2 into E naught, okay. Reduced by 20% means 0.8, that is 100 minus 20, we will take 100 minus 20, the remaining 80% will be left. So 0.8 into E naught. This is the second thing. The third is if electric field is reduced to 30%, let us suppose. Okay, reduced to 30% means 0.30 times of E naught. Okay, that means it has reduced to 30%. Okay, this is the maximum value E naught, and now it is reduced to 30%. So it is 0.30 E naught, reduced to 30%. Okay, and it is reduced by 20% means this portion is 20%. So if this portion is 20%, then it is left as 0.80. Okay, and if electric field is reduced by 20 dB, okay, if it is given as 20 dB, then first of all convert it in this dB into the normal value. Because it is electric field, we are using the 20 dB. Okay, so this is 20 log of x, suppose. So x is equal to 10 to the power 1, which is 10. Okay, so x is equal to this 20 divided by 20 will become 1, and we will take anti-log, then it is 10. So that will become, because the factor x is coming as 10, then we will reduce E naught by factor 10. Okay, that means we will write E naught by 10. If it is reduced by 20 dB, then also E naught by 10. If it is reduced by factor 10, then also E naught by 10. If it is reduced by 20%, then 80% will be left. And if it is reduced to 30%, then 30% is directly written. Okay. So I hope now it is clear, Janvi. Rupesh, we take 20 or 10. It depends on whether you are calculating electric field or magnet power. Okay, whether you have electric field or power. Thank you, TK. Yeah, actually, this point of time, I don't want to bring some very tough questions. That is why मैंने यहाँ पे moderate question रखा है. ठीक है, जो ज़्यादा tough भी नहीं था और ज़्यादा easy भी नहीं था. कुछ क्वेश्चन ज़्यादा easy थे, कुछ क्वेश्चन moderate level के थे. क्योंकि अब से 4 to 5 days बचे हैं एग्जाम को, तो मैं अगर टफ क्वेश्चन लेके आता सुपर 11 के नाम पे, तो आप हो सकता है कि डिमोरलाइज हो जाते हो और आपको लगता है कि यार मैंने कोई टॉपिक पढ़ा नहीं, ऐसा भी फील हो सकता था. तो अब यहाँ पे अब टाइम है कि यार हम जितना पढ़े हैं बहुत अच्छे से पढ़ लिए हैं. डोंट वरी अबाउट इट. Whatever you have studied, you have prepared well. So just crack the exam. Okay, don't worry what new question will come. Don't worry about it. Whatever you have studied, that is itself sufficient to get the top rank. Okay, whatever you have studied in all the subjects, it is itself sufficient to get the maximum marks, maximum good rank. So that is why just don't worry about the tough questions now. ठीक है, चलो. सो गेट एंड ईएसई टेस्ट सीरीज वगैरह अगर आप देख रहे होगे, लिंक जो है आपको डिस्क्रिप्शन में दिया है हुआ है ना, जिसमें आपको बहुत सारे टॉप 60 क्वेश्चंस मिल जाएंगे, मॉक टेस्ट एनालिसिस, सब वर्चुअल कैलकुलेटर एक्सेट्रा मिल जाएगा. तो गाइज आई थिंक अब हम लोग किसी भी सेशन के साथ नहीं मिलने वाले हैं. अब हम लोग सीधा मिलेंगे गेट एग्जाम के एनालिसिस के साथ. तो ऑल द वेरी बेस्ट टू ऑल ऑफ यू. आई होप कि आपसे सारे ईएमटी कम्युनिकेशन और सारे सब्जेक्ट के क्वेश्चन बन जाए. ठीक है, और हम लोग मिलेंगे एनालिसिस के टाइम पे. एंड in the analysis we will check our answers, we will analyze it, and we will learn something from there also. And just all the best, and be careful. Don't worry about anything else. Don't focus about the result. Just what is the process you have done, you have go through till now in this year, just stick with that. The plan you should have, how you are going to approach in the gate 23 examination, whether you are going to solve the 1 mark question first, whether you are going to solve the aptitude mathematics question first, that one strategy you should have. Otherwise, Amrinder, I think I was explaining in the English only. Maybe sometimes I spoke Hindi, but I don't think that every time in the solution I was speaking in English maximum. Okay, so we'll meet on the day of GATE examination with the analysis. So don't forget, okay, don't forget to come and share your questions so that we can give you the solution. And don't try to remember questions of EMTF communication and share it with me in my WhatsApp number so that we can discuss in the GATE exam analysis. Okay, thank you.